Let's take a look at this integral taken from the JEE Advanced 2018 to integrate from x equals 0 to 1/2 of 1 plus square root of 3 divided by the 4th root of x plus 1 whole squared times 1 minus x all to the power 6. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. To evaluate this integral, I'm going to rewrite the expression inside the 4th root at the denominator to be x plus 1 whole squared times 1 minus x whole squared times 1 minus x to the power 4. In other words, I'm just splitting the 6 powers into squares times to the power 4. Then, making use of the identity of the difference of squares, I can combine these two terms. And so we get 1 minus x squared all squared times 1 minus x to the power 4. Apart from making use of the identity of difference of squares to combine some of the terms, the second reason for me to do this is that I will result in having 1 minus x to be now to the power 4. And when I take this whole expression to its 4th root, this index will be cancelled out. So now the integral becomes from 0 to 1/2 of 1 plus root 3 dx, and the denominator is now 1 minus x squared and the whole thing to the power 2 over 4, which is 1/2. So use the square root sign, multiply by 1 minus x. At this point, I'm going to make use of a trigonometric substitution because we have a term of the form square root of 1 minus x squared. And it's a common trick to now let x equals sine theta, so that the square root of 1 minus x squared is the square root of 1 minus sine squared theta, and that's cos theta. Furthermore, dx, after differentiating, we have cosine theta d theta, so we can see that something might cancel out. And we also have to take care of the limits. For the lower limit, when x is 0, theta is also 0. When x is 1/2, theta is power of 6. So the integral becomes from 0 to power of 6 of 1 plus root 3, all multiplied by cos theta d theta divided by cos theta multiplied by 1 minus sine theta. And so I can take out 1 plus root 3 from the integral, and the cosine cancel out, and what remains is just 1 minus sine theta. Now at this point, I'm going to multiply both the numerator and the denominator by 1 plus sine theta. The reason is that it's not convenient for us to have addition or subtraction at the denominator because it makes it harder for us to split the fractions. But if I multiply by 1 plus sine theta, I would then get one minus sine square theta, and I can rewrite that as cosine square theta d theta. Just a remark. If I multiply these two, it is 1 minus sine squared, and that means it's cosine squared. Now, there's only one term at the denominator, so I can split the fraction. It becomes 1 over cosine squared plus sine squared over cosine squared. I can rewrite that as sine over cosine times 1 over cosine. We'll see the benefit of writing in this way, in this step. Now the integral becomes secant square theta. The 1 plus cosine square is secant square theta, added by sine over cosine is tangent theta, multiplied by secant theta. So now we can integrate each term separately. We have secant square after integrating to become tangent theta, and tangent times secant will become secant theta after integrating. So we've managed to integrate the whole thing, and what remains is just to handle the upper and lower limits. Tangent of power over 6 is root 3 over 3. Secant power over 6 is 1 over cosine of power over 6, so that's 1 over root 3 over 2. So I'm going to rewrite the first term, tangent power over 6, to be 1 over root 3 instead, and secant to be 2 over root 3. That's the reciprocal of root 3 over 2, minus 0 plus 1. The reciprocal of 1 is still 1. So now we have the two fractions added together is 3 over root 3. So that's root 3 and minus 1. And we can make use of the identity of the difference of squares to get its root 3 whole squared, that's 3, minus 1 squared, so it's 2. And this is the final answer.